Hey guys, Mr. Pauller here. In this video, I'm going to show you how to combine two series of data into a single chart using Google Sheets, and I'll also show you how to run linear regression analysis for both of the data series. The graph I'm going to show you how to create is an experiment to determine the density of two different liquids, water and isopropyl alcohol. I've already labeled three columns in the Google Sheet. Volume is the independent variable in this experiment, so that's been placed into column A. And then the two liquids, water and isopropyl alcohol, have been placed into columns B and C. So let's go ahead and start filling in the data. So the water data set with a volume of 1.95 milliliters, there was a mass of 2 grams. 4 milliliters was 4.1 grams. 6 milliliters was 6.1 grams. 8.1 milliliters was 8.2 grams. And then the final measurement for water was a volume of 9.9 milliliters and a mass of 9.9 grams. Now we're going to go ahead and enter the data for the isopropyl alcohol. Now notice I'm entering the volume still in the A column, 1.7. The mass goes into the isopropyl alcohol column, 1.4 grams. 3.95 milliliters of alcohol had a mass of 3.3 grams. 5.4 milliliters was 4.5 grams. 7.15 milliliters had a mass of 6.2 grams. And our final data set for isopropyl alcohol had a volume of 9.85 milliliters and a mass of 7.9 grams. Now I want to take advantage of some ability to do some sorting in the Google Sheet. So I'm going to freeze one row of my data, then I'll select my first column for volume. And by sorting, I can sort all the volumes to go in ascending order from 1.7 up to 9.9. Then I click and drag to highlight all of the data, and I'm choosing Insert Chart. And in a moment here, we should see the chart pop up. And there it is. Now I'm going to go ahead and resize this. And I want to make sure that I choose the correct chart type. I want to select a scatter chart. And then I'm going to go to Customize in order to display the equations that I want for my linear regression analysis. So under Series, I'm selecting Trend Line. I want to make sure that I've selected Linear. I have. I'm going to use the equation as a label and show the R-squared value. Now, if I go into Legend, I can change the position and the size of my legend. So I'm making it bigger, and I can move it to the right-hand side. Now I want to also show you how to change the labels for the axes. So if I'm looking at my x-axis, let me just resize and move my chart around a little bit so you can see that more clearly. So if I click into the box where it says volume, I can type directly into that box like I'm doing right here, typing ml for milliliters. Now there's another way that I can do this too. So if I set it back how it was, so if it just says volume, and I click into the box under the chart where it says volume, we'll just move this around and make this chart a little bit bigger even so you can see that more clearly. And just move this into the middle of your screen. Now if I click on that volume box, you can see the chart editor will pop up, and I can actually type directly into the chart editor where it says volume. I can add in milliliters right there, and you can see that it shows up now on the chart, and I can change the font size as well. So I can go to a larger font size and make it easier to read. Then under chart and axis titles, I'm now going to the vertical axis, and I'm adding in my label mass with units of grams. I'm going to resize that, and I realized my x-axis was actually a little smaller font, so I'm going to change that to make it the same. Now I'm going to go ahead and edit the title of this chart. Instead of water and isopropyl alcohol, I want the title of the chart to represent both the independent and dependent variable. So it's mass versus volume of two liquids. Remember, the two liquids are water and isopropyl alcohol. Now the equations that display give us the densities of the two liquids. Okay, so as we analyze the two equations that we have now displayed on our graph, we see that for water, the equation is listed as 0.995x plus 0.0983. So this is written in the form of y equals mx plus b. It just doesn't show you the y. So the mx is 0.995x. That means that the slope, m, equals 0.995. Now, if we think about what this graph is telling us, the rise over run is the slope. On this particular graph, the rise is the mass and the run is the volume. So the slope, rise over run, equals mass over volume. That means that the slope on this graph is actually telling us the density. So the density in our equation for the line of best fit shows us that the slope is 0.995. That actually means that experimentally, we have determined the density of water to be 0.995 grams per milliliter. This compares really well with the accepted value. At 20 degrees Celsius, the known value for the density of water is 0.998. So we're very, very close to that value, just a small bit off due to some experimental error in measurement. For the isopropyl alcohol, the equation we have here is y equals 0.81x plus 0.114. Now, for both of these, to determine the density, my intercept values are not critical, so I'm not going to talk about those further. But let's go back to looking at the slope for isopropyl alcohol. Here we have a value of 0.81. This means that experimentally we have determined that the density of isopropyl alcohol is 0.81 grams per milliliter. This also compares very well with the accepted value for isopropyl alcohol at 20 degrees Celsius, which is very close to the temperatures when I carried out the experiment. So the accepted value for isopropyl alcohol is 0.785 grams per milliliter. I will post another video in the future discussing how to calculate percent error calculations, which we would use in order to compare an experimental result like these with the theoretical or known values that I've just shared with you for the two liquids, water and isopropyl alcohol. All right, everybody, thank you for watching. I hope you found this video informative and helpful if you are working on using Google Sheets to analyze data from your science experiments. If you did, please consider giving it a like and leaving a note or a question for me in the comments. And don't forget to subscribe and ring the bell if you want to keep up with all the new videos I'm posting about chemistry, biology, and other cool science stuff. Until next time, stay curious.